is 10,000 meters. Does that make sense? Okay. And you're always moving either to the left or the right. Whatever you're moving on the chart, the jumping chart, is the same direction you're moving your decimal. Okay. So again, here we have 35. Your decimal would be right there. Okay. And we're going 35 centimeters to millimeters. So I come to centimeters, and I go 1 over to the right. Does everyone agree with that? So that means my decimal will jump one place. So I have 350 millimeters.
It's weird how that works.
Pardon? It's because they're all proportional, right? Because we're within the same unit. We're in metric.
Yeah.
But it makes it easy. As long as you have this, it makes it easy. Everyone okay with this? So jumping decimals. Okay. 3 yards is how many meters? So now it even says in the beginning, now all of a sudden we're going to need to be working with our actual conversion chart, okay? Yeah. Because we're not in the same units. So now we're going to be doing something called the Zorro method. Has anyone heard Zorro? You might have also learned cross multiplication, okay? So the cross multiplication and the Zorro method are the exact same thing. The Zorro method just puts it all into one Z pattern, and it keeps track of where you're multiplying and where you're dividing. Okay? So we have 3 yards, and we want to know how many meters. So we're going to look down at our conversion chart, and I'm going to look at where I am between yards and meters.
So 1 yard equals 0.9144 meters.
1 yard equals, okay, perfect. So what I do is I put this as a fraction. So 1 yard equals 0.9144 meters. Now the rule here is I have yards on top and meters on the bottom. Does everyone agree with that? Just in your next fraction next to it, keep yards on top and meters on the bottom. As long as you keep the units the same across the top and across the bottom, no matter which order you put them in, it'll always work. Okay, so I know that I have 3 yards, so it's going to go on top. And I don't know how many meters are, so I'm going to put an X in there. Everyone agree with that? So now, the Zorro method is, all you do is you circle your X, or your unknowns. Starting from that point, you draw a Z. Okay? The first 2 numbers that hit on the Z, you multiply, and then you divide by the third number. So, in this case, it would be X equals, the first number I hit is 0.9144. The next one I hit is 3. So those 2 get multiplied. Then I divide by the third, which it hits last, the 1. Pardon? No, it doesn't. In this case, it doesn't, because a 1 is a 1, right? So the answer here, but sometimes it will, okay? So 2.7432. And in this case, it doesn't actually tell us how many decimals it wants to go to, so we're going to just go to 2. Okay? It doesn't tell us. So our answer is 2.74 meters. 2.74 meters. Okay, we do it again. Kilometers to miles. Okay, kilometers to miles. So I see that 1 mile is equal to 1.609 kilometers. So I'm going to go 1 mile is equal to 1.609 kilometers. Sorry about that. Okay, again, because I had miles on top and kilometers on the bottom, I stick with the same form I used. I have 4 kilometers in this case, and I don't have any miles. So my X is on the top this time. It absolutely does not matter because I circle my X, and I draw my Z starting from that X. The first 2 numbers that hit get multiplied, the second divides. So I have X equals 1 times 4 divided by 1. Divide by 1.609. Yeah, I'll go to 2 decimal places. So yes, it would be 2.49. 2.49, and that is rounded. That is rounded. Now, can everyone just look up for a second? As soon as I see you do this Zorro method, I assume that you know to do this multiplication and division. If you want to show me that secondary step, go ahead. But it's not necessary, okay? I assume as soon as you know Zorro, the first 2 get multiplied, then divide by the third, okay? Okay, try E. Try E. Okay, so first things first, I'm going to look for inches to centimeters, or centimeters to inches. And I did see it. 1 inch over 2.54 centimeters. So that means I'm going to have inch on the top and centimeters on the bottom. So I know in the question it gives me 68 centimeters, I don't know. Again, I circle my X, draw my Z. For Zorro, X equals first 2 numbers that hit, so 254 times 68 divided by the third. So I got 172.72. So X equals 172.72. Okay, and then feet to meters. So feet to meters. So I have 1 foot is equal to 0.3048 meters. Foot is on top, meters on the bottom. I know I have 2 feet, and I do not know how many meters I'm going to have. I draw my Z. I get X equals 0.3048 times 2 divided by 1. Sorry if I'm going fast. Again? Is it? Yeah, 0.61. So 0.61, and that is rounded. That is rounded.
I just put like 6 letters out for it.
Yep, that's. I just sometimes the decimal gets lost on the start board, so that is why I did it that way. The first 2 lessons seem to go on forever. Okay, we're getting there. I promise the first day or so sort of is not the most fun. I'm talking at you a lot, but it's because I'm trying to get all of the review sort of stuff done. All right, I promise it'll get better. Okay. All right, Pythagorean theorem. Pythagorean theorem, which is always done 50% right, 50% wrong. If you guys are solving for the hypotenuse, which is the diagonal of a triangle, you always do it perfectly. If the hypotenuse of a triangle is given, most people mess it up. Okay?
They still add.
Because they still add instead of subtract. Now, Pythagorean theorem, if you go into any sort of construction or anything like that, it is probably the one thing that you use most often because it's an easy way to calculate angles. So, if you flip to the second side of your sheet, at the very bottom, right under the chart is your Pythagorean theorem. Okay, so it's also up on, where is it? 1 second. Pythagorean theorem's up there on the trig reminders right next to the clock. It is also right here up on this top one. Okay, so it's around the room as well. So again, you just need to remember, everyone look up for a second, because you all say, oh, I know it, Helen, I know, but you just forget. Just remember, this side, the diagonal is always the hypotenuse. Then these, it doesn't matter, A, B, B, A, it doesn't matter. Okay? But the diagonal is always C. The diagonal is always C. If sometimes they're mean, and they relabel a triangle and they throw A as the diagonal, I don't care, scratch those letters out and rename it. Always have C as your diagonal. Okay? If you have C as your diagonal, you will always be able to use those two. Or you will always be able to use these two. You will never mess it up, okay? So, this one is very nice because, equals. You guys are probably looking at me like, what? You put an H there. Okay, this one is very nice because we're solving for the hypotenuse. So, we use C squared equals A squared plus B squared. And we're good to go. Okay? C squared is equal to 13 squared plus 9 squared. So 13 to the exponent 2 plus 9 to the exponent 2, I get 250. But I want to get C by itself. How do I get rid of that exponent of 2?
Square.
Square, thank you. So square root of C squared equals square root of 250. I'm going to just come up over here. C equals the square root of 250 gives me 15, does it tell me how many? 1 decimal place. Okay, it says 1 decimal place. So 15.8 centimeters. Don't drop your units on these questions. Okay. Sean, right? Sean, because you just did 11 colors, this stuff might be boring in the beginning.
Yeah,
okay?
it's fairly...
Yeah, because you literally just did it. Yeah. And like the first, some of the first whole unit is reviewed for you.
When it's asking me to solve for triangles, do I have to use Pythagorean theorem?
I know what you're talking about. Would you ever do sine law for sine law? Technically,
right angle triangles.
Yeah. So if it was if I'm looking for a right angle triangle, I'm going to be looking for SOHCAHTOA or Pythagoras.
All right, that's fine.
Okay. Use sine law and cosine law for non-right angles.
Okay.
Okay. Next, I have C, right? So on this equation here, it says A squared is equal to C squared minus B squared. Now it doesn't matter. I have B here, so it's going to be B squared is equal to C squared minus A squared. C, your diagonal, is always the biggest number, right? It's always the biggest number. So you're going to be always subtracting from that value. So B squared is equal to 3.2 squared minus 1.8 squared. So 3.2 to the exponent 2 minus 1.8 to the exponent 2. If you don't know how to use the calculator, just ask me. I will help. I get B squared equals 7. Now I'm going to take the square root of B squared and the square root of 7. So I get, I'm just going from here because I don't want to write down, B equals 2.6 centimeters. Am I going too fast? Please tell me if I am, okay?